Objective. Equations with variables on both sides. Definition number one, an identity is an equation that is true for every value of the variable. So here's an example, 2x equals 2x. No matter what value you plug in for x, the equation is going to be true on both sides. So if x is 4, 2 times 4 is 8, 2 times 4 is 8, 8 is always equal to 8. So we say that this equation is an identity. It also means that there are an infinite number of solutions. Infinite solutions. That means x could be any real number. Big number one. An equation has no solution if no value of the variable makes the equation true. So 2x equals 2x plus 1. No matter what value you choose for x, these two sides of the equation will never be true. And you can plug in an infinite number of numbers and it's never going to be true. So we say this equation has no solution. Steps to solving equations with variables on both sides. Distribute. So if there's distributing that needs to happen, you do that first. Then clear the fractions. Again, this is optional. It makes the equation prettier. And number 3, get the variable on one side of the equal sign and constants on the other side. So we want our variable, our letter, on one side, and we want our numbers by themselves on the other side of the equal sign. Number 4, get the variable by itself for the solution. So we want our variable, maybe x or a or b, by itself, so only one of them, and it has to be positive on one side of the equal sign. Example number 1, 6x minus 2 equals x plus 13. So we have x's on both sides of the equal sign. We need them all to be on one side. We don't have to distribute, which was step 1, because we don't have that in this problem. We again don't have any fractions, so we can skip step 2. And step 3 says get the variable on one side. So I'm going to move my variables to the left. So I subtract x from both sides. This is 1x, so I subtract 1x from both sides of the equal sign. These x's will cancel. So I just have 13. 6x minus 1x is 5x. Bring down the minus 2 and bring down 13. Now this looks like a two-step equation that you are familiar with solving. The opposite of subtracting 2 is adding 2 to both sides. These 2's now cancel out. 5x comes down. 13 plus 2 is 15. 5x equals 15. This is 5 times x. So the opposite is to divide by 5 on both sides of the equal sign. These 5's will cancel. X equals 15 divided by 5 is 3. And you can plug in 3 to both sides where x was at the beginning to check. So I'm just going to do this verbally. Pretend like x is 3. 6 times 3 is 18. 18 minus 2 is 16. So I got 16 for the left side. Again, pretend like x is 3. 3 plus 13 is 16. So I got 16 for the right side. 16 is always equal to 16. So my answer is 3. Example number 2. 2n minus 5 equals 8n plus 7. Again, I have variables on both sides of the equal sign, so I need to move them all to one side, and I'm going to move them to the left. This is a positive 8n, so I'm going to subtract 8n from both sides. These cancel. Bring down 7. 2n minus 8n is negative 6n. Bring down the minus 5. Now we have a two-step equation. So we need the variable by itself. This is minus 5, so the opposite is to add 5 to both sides. The 5's cancel. Negative 6n comes down. 7 plus 5 is 12. This is negative 6 times n, so the opposite would be to divide by negative 6. The negative 6's cancel. You do the same thing on the right side. 12 divided by negative 6. A positive divided by a negative is a negative, and 12 divided by 6 is 2. you can take negative 2 and plug it in where n was in the original equation to check your answer. Example 3, 30 minus 7z equals 10z minus 4. I have z's on both sides, so I'm going to subtract 10z from each side. It's a positive 10, so the opposite would be to subtract. These 10s cancel. Negative 4, keep the sign with the 4, so negative 4 comes down. This is negative 7z minus 10z, negative 17z. The 30 comes down. Now this is a two-step equation. Subtract 30 from both sides. We want our constants on the opposite side. It's positive 30, the opposite is to subtract 30. Subtract 30 from both sides. These 30s cancel. Negative 4 minus 30 more is negative 34. Negative 17z comes down. Negative 17 times z, so the opposite would be to divide by negative 17. Those cancel. Negative 34 divided by negative 17. A negative divided by a negative is a positive, and 34 divided by 17 is 2. You can take 2 and plug it in where z was in the original equation to check your answer. Example number 4. 4p minus 10 equals p plus 3p minus 2p. Well, you can see the variable 4 times in this equation. So let's combine like terms first. So on this side I don't have any like terms, but on the right side I have 1p plus 3p, that's 4p, minus 2p. 4 minus 2 is 2. So you see where 2p came from. Now I'm not dividing, I was just underlining it to show you what the new value was. Now I have 4p minus 10 equals 2p. So I have the variable on both sides of the equation. I'm going to subtract 4p from both sides. Now that's going to move p to the right side. You could subtract 2p from both sides and your answer will be the same. So here if I subtract 4p from both sides, those cancel, bring down minus 10. 2 minus 4 is negative 2, and they both have p, so negative 2p. This is negative 2 times p, so we divide both sides by negative 2. Those cancel. Negative 10 divided by a negative 2. A negative divided by a negative is a positive. 10 divided by 2 is 5. 5 equals p. Well, that's the same thing as writing p equals 5. So either one of these answers is acceptable. Let's do this one together. 6x equals 4 times the quantity, that means put it in parentheses, x plus 5. So step 1 says distribute. I have to distribute in this problem. So I'm going to say 4 times x and 4 times 5. Well, 4 times x is 4x and 4 times 5 is 20. 6x comes down. I have variables on both sides of the equation. I need them all on one side. So I'm going to subtract 4x from both sides. That's going to move my x's all to the left. These will cancel. 6x minus 4x is 2x. The 4x's canceled, so I still have 20 on the right side. 2x equals 20. Now this is 2 times x, so we are going to do the opposite, which is to divide by 2. The 2's cancel, and x equals 10. 20 divided by 2 is 10. And you can take 10 and plug it in where x was in the original to check. So let's do that. X times 6 would be 6 times 10 is 60. So I got 60 on the left side. If I plug in 10 where x was here, I have to do what's in parentheses first according to the order of operations. So 10 plus 5 is 15, and then times 4, and 15 times 4 is 60. So you see I got 60 on the left and 60 on the right, and those are equal to each other. So x equals 10 is correct. Example 6. 3 times the quantity, so in parentheses, x minus 2, plus 8 equals 5 times the quantity, x plus 4. I have to distribute on both sides of this equation. So let's do that. 3 times x is 3x, and 3 times a negative 2, remember this sign goes with that number, so 3 times negative 2 is negative 6, carry down to plus 8. Distribute on the right side, 5 times x, 5x, and 5 times 4 is 20. Now let's combine like terms. I have negative 6 plus 8, so I have 3x plus 2. Negative 6 plus 8 is 2. And 5x plus 20, still over here. I need all of my variables on the one side and all of my constants on the other. So I'm going to move my variables to the left side. Subtract 5x from both sides. The 5x's cancel. 3x minus 5x is negative 2x. Carry this down. Carry down 20. Now I need the constants on the other side. I have my variables all on the left. I need my constants on the other side, so I'm going to move them to the right. To move positive 2 to the right, I need to do the opposite. So subtract 2 from both sides. Those will cancel. Negative 2x comes down. 20 minus 2 is 18, and we're almost done. I have negative 2 times x, so I'm going to divide both sides by negative 2. So x equals negative 9. 18 divided by negative 2 is negative 9. And you can take negative 9 and plug it in where x was on both sides of the equation to check your answer. All right, 4 more examples. Solve if the equation is an identity, write identity, and write infinite solutions. So if it comes out to be 2x equals 2x, or something on the left is equal to something on the right, then we're going to write that it is an identity and that there are an infinite number of solutions. If there's no solution, we're just going to write no solution. Now, if it's not infinite and there's not no solution, which means there is a solution, we'll state what the solution is. Example number 7. 18x minus 5 equals 3 times the quantity 6x minus 2. So I see I need to distribute here. So 3 times 6x is 18x, and 3 times a negative 2 is negative 6. Now I have variables on both sides, so I need to move my variables all to one side. I'm subtracting 18x from both sides. Well, in this case, they happen to have the same variable on both sides. So those cancel and those cancel. Bring down minus 5, bring down minus 6. Negative 5 equals negative 6. Well, that's never true. Negative 5 is not equal to negative 6, so we put a slash through the equal sign, which means not equal to. So this statement is not true. This equation has no solution. Example 8. 9 plus 5a equals 2a plus 9. I don't have to distribute, I don't have any fractions, but I do have variables on both sides of the equation. So I'm going to subtract 2a from both sides. So I'm moving all the a's to the left. 2a minus 2a, those cancel. The 9 comes down. 5a minus 2a is 3a. This 9 comes down. So I have 9 plus 3a equals 9. I need all of my constants on the right side since my variable's on the left. So I'm going to subtract 9 from both sides. Well, those 9's cancel, and 9 minus 9 is 0. 3a equals 0. Well, I'm not done yet. I have 3 times a, so the opposite is to divide both sides by 3. 3 divided by 3 is 1, so I have 1a, and it's positive. 0 divided by 3 is 0. So I don't have no solution. I actually do have a solution, and it is 0. Your answer can be 0. That's okay. All right, example 9. The example's in purple. In black is where I have multiplied to get rid of the fractions. 3/5 k minus 1/10 k equals 1/2 k plus 1. I have 3 fractions in this equation. In order to get rid of all of the fractions, I need to multiply by the least common denominator, and we've done this before. So 5, 10, and 2. The smallest number that 5, 10, and 2 all go into evenly is 10. So I multiply by 10 all the way through the equation. There are 1, 2, 3, 4 terms in the equation, so I multiply each one by 10. 10 times 3/5 k is 6k. 10 times negative 1/10 k is negative 1k. 10 times 1/2 k is 5k, and 10 times 1 is 10. Now I need to combine like terms. 6k minus 1k is 5k. This part comes down. 5k plus 10. Now I need all of the variables on one side and all of the constants on the other. So, since 10 is over here and it's a constant, I need to subtract 5k from this side. So subtract 5k, we'll do the same thing to the other side. Those cancel, 10 comes down. 5k minus 5k is 0. 0 is not equal to 10. 0 is not equal to 10. So this is not true. Therefore, those 3 dots in a triangle mean therefore. There is no solution to this equation. No matter what value you choose for k, the left side of the equation will never equal the right side. And our last example, example 10, 14 minus the quantity, so in parentheses, 2g plus 5 equals negative 2g plus 9. Now, you see this negative outside the parentheses? I put a 1 in there. If you don't see a number with that negative, you know that it's a 1. So I need to distribute first. Negative 1 times 2g is negative 2g, and negative 1 times 5 is negative 5. After you distribute, if you can combine like terms, you should do that. 14 is positive, minus 5. So 14 minus 5, remember this sign stays with that number. 14 minus 5 is 9, that's where this 9 comes from. Negative 2g comes down. This side of the equation you can copy again. We haven't done anything over there. I need all of my variables on one side, all of my constants on the other. So it doesn't matter which side you add 2g to because they are the same. So I'm going to say add 2g over here, well add 2g over here. They cancel on both sides in this case, and the 9's come down. 9 equals 9. Well, this is always true. So, therefore, it's an identity. This equation is called an identity, and there are an infinite number of solutions. If you choose any number you want for g, if g is 1, if g is 5, if g is negative 40, you're going to get the same value on the left side and the right side of the equation.